brain can detect a pattern before you see it. In the autumn of 1962, a young psychology graduate named Diane Weber sat alone in a dimly lit lab in Palo Alto. The air hummed with the scent of old vacuum tubes, warm solder, and the bitter tang of cold coffee. A reel-to-reel tape recorder spun patiently, hissing out waves of unstructured static. On the wooden desk before her, a single incandescent bulb flickered unpredictably on, off in a sequence engineered to have no order at all. Diane's task was deceptively simple: press a button each time she anticipated the next flash. For the first 10 minutes, she felt almost foolish. Her guesses were wild stabs in the dark, her timing consistently off. The light pulsed without rhythm, without mercy. But then, slowly, something shifted. A quiet intuition began to stir. Her fingers started to move, not after the flash, not during, but a fraction of a second before the bulb lit up. Not always, but often enough that the data rolling from the printer began to tell a new story. The researchers, who had been leaning against the back wall, stepped closer. The tape recorder seemed to whir with a new urgency, as if it, too, sensed the change. And here's what's extraordinary. Diane wasn't guessing. She wasn't just getting lucky. Wires ran from her scalp to an EEG machine, tracing the quiet electricity of her thoughts. And every time her finger pressed that button early, a distinct spike appeared on the graph, a sharp, clean waveform that shouldn't have been there. It was a signal from somewhere deeper than consciousness, a murmur from the brain itself, whispering, "I already know." The team named it precognitive resonance. It was as if the mind could tune into a hidden frequency like a radio, suddenly finding a station broadcasting just beneath the noise. They repeated the experiment with new subjects, with auditory cues instead of light, with varying intervals. Each time the spike returned, always the same shape, always the same precise timing, right at the edge of perception. But there was a problem. The lab's director, Dr. Elias Voss, received his funding from the Pentagon. They weren't interested in curiosity, they were interested in combat. They wanted soldiers who could sense ambushes before they happened, commanders who could predict enemy strategy through instinct alone. And when the implications of the research became clear, the letters began to arrive. First, formal requests, then urgent memos, finally threats. The data was declared classified. The experiments were shut down. The team was dispersed. Diane Weber was made to sign a non-disclosure agreement under threat of losing everything she'd worked for, yet the discovery refused to die. In the years that followed, researchers in Tokyo, Milan, and Rio documented the same spike, the same shape, the same timing flickering into existence just before a pattern revealed itself. But each time, the funding would dry up, papers were rejected without review, scientists were quietly discredited, their reputations smeared. The finding was buried over and over beneath layers of institutional silence. Then, in 1978, a physicist in Rome named Marco Bianchi published a paper that approached the phenomenon from another angle. He wasn't studying brains, he was studying resonance in quantum fields. He described a non-local humming in the fabric of reality itself, a 40 Hz frequency that certain materials and perhaps certain minds could subtly detect. His equipment recorded the same spike, not in human subjects, but in crystals, in water, even in the silent spaces between atoms, 40 Hz. The same number Diane's team had circled again and again in their lab notes. The paper passed peer review. It was cited exactly once. Then it disappeared, pulled from journals, scrubbed from conference archives. Marco Bianchi was offered a lucrative corporate position. He accepted. The spike, once more, went unmentioned. But 40 Hz is no arbitrary number. It's the frequency of gamma brain waves, the rhythm your mind falls into when it's making connections, solving puzzles, seeing the whole before the parts. It's the hum of insight itself. Decades later, in 2020, a research team in Sao Paulo decided to run the experiment one more time. Same random light flashes, same response button. But this time, They introduced a low, steady, 40 Hz tone in the background, almost subliminal, like the distant rumble of a generator. What happened next was stunning. The spike didn't just reappear, it amplified. It doubled, then tripled in strength. Participants weren't just occasionally anticipating the flash, they were predicting it, consistently, accurately, almost effortlessly. Their brains weren't guessing. They were listening to a rhythm humming just below the surface of reality. The new study was published to acclaim. It was shared widely, celebrated as a breakthrough. But in all the excitement, no one spoke of the earlier experiments. No one mentioned the suppressed research, the silenced scientists, the military's interest. The story was framed as a discovery, not a recovery, a chapter opening, not finally being read. So we're left wondering, what else is your brain hearing that you haven't yet learned to listen to? What patterns are vibrating all around you, hidden in plain sight? What truths have been tucked away not because they were false, but because they were too powerful? The map of human understanding isn't just incomplete, it's been censored. Some frequencies have been deliberately turned down, but they never quite go silent. Explore the hidden patterns around you and question what else might be hidden in plain sight.